Hi there, this is going to be my 8th video about the Gauss Seidel method, and I'm basically going to take the former metrics, so the metrics I used in the other video, in the previous one, and basically going to start from a completely different point in order to show you that it doesn't really matter when you start, it's just a matter of how fast it's going to convert to your desired value. So let's take the very same matrix we used in the other video. It was -4, -1, 0, 1, 0, -2, 1, 0, 0, 1, 3, 1, 0, 0, 1, -2. So this one was our matrix A, and it's still going to be our matrix A. X was our vector x, y, z, w equals c 1, 0, 1, 2. So everything is the same. This is still gonna be our system of linear equation. -4x minus y plus w equal to 1, -2y plus z equals 0, y plus 3z plus w equal 1, and z minus 2w equal 2. So exactly as I did before, I'm basically gonna just get x, y, z, and w out of those equations without solving them, but basically getting those variables in function of other variables. So if I do this, I'm basically gonna get -4x as before, 1 plus y minus w, -2y equals 0 minus z, 3z equal to 1 minus y minus w, and -2w equal to minus z, which as before basically going to give me -x equal 1 over 4 plus 1 over 4y minus 1 over 4w, so -y equal to -1 over 2z, z equal to 1 over 3 minus 1 over 3 y minus 1 over 3 w, and w is, well, negative w is 2 over 2, which was going to give me 1 minus 1 over 2z. And again, this is basically going to give me x equal to -1 over 4 minus 1 over 4 y plus 1 over 4 w. Y is actually 1 over 2, so 1/2 z. Z is 1/3 minus 1/3 y minus 1/3 w, and w is -1 plus 1 over 2z. Okay, so far so good. Everything was exactly as in the former video, so nothing really changed. But this is how we're gonna change now. So I'm gonna start with the iteration 1, step 1, as I did before, but I'm basically gonna use values iterations. I'm basically going to use a completely different set of values. So I'm going to start with each value to 1. So x equal 1, y equal 1, z equal 1, and w equal 1. So those are basically going to be our first guess, for this system linear equation. We know they're not true, but I just want to show you that it doesn't really matter where you start from. It's always gonna convert to the desired value. It's just gonna be faster or slower. So let's start with x. X is basically given by this equation as it was before, so -1 over 4, which is a scalar, it's not dependent by anything, minus 1 over 4y, so it's dependent by y, which is going to be 1 because our first guess is 1, plus 1 over 4 w, which is going to be times 1, so because our first guess is 1. So basically this is going to become -1 over 4 minus 1 over 4 times 1 plus 1 over 4 times 1. And it's going to give us -1 over 4 minus 1 over 4 plus 1 over 4. So this is basically gonna be, well, -1, -1 plus 1, -1 plus 1 nullify themselves, and this is basically -1/4. All right, so let's go on. I'm gonna go to iteration 1, step 2. So those are still gonna be my values. So x is now going to be equal to -1/4, y is equal to 1, c is still equal to 1, and w is still equal to 1. I'm just going to underline those y, z, and w because those are going to be the one that have to find. I still have to find. So basically y is given by this equation here, which is basically y equal 1/2 of z. So y is equal to 1/2 of z. Z was equal to 1, so 1/2 of 1. And therefore, y is actually equal to 1/2. There we go. Let's go on. Iteration 1, step 3. So iteration 1, step 3. There we go. Oh, well, I forgot to... well, it doesn't really matter, but I forgot to insert iterations and values on top of the table. Okay, so iterations and values once again. So x is actually going to be equal to -1/4, y is going to be equal to 1/2, we just found it, z is still equal to 1, and w is still equal to 1. And I'm just going to underline z and w. Okay. So now we're looking for z. Z is going to be given by this equation here, which is basically 1/3, which is a scalar, it's not dependent by anything, doesn't have variables, minus 1/3, y is dependent by y, minus 1/3 w, so it's dependent by w. And therefore, z is actually going to be given by 1/3 minus 1/3 times 1/2, our new value for y, minus 1/3 times 1, which is going to give us 1/3 minus 1/6 minus 1/3. So z is actually equal to 2 minus 1 minus 2 is 6. So z is actually equal to -1/6. Okay, so far so good. Let's go on. Iteration 1, step 4. So, well, they're going to be our, let me squeeze it here. So these are going to be our values, those are going to be our iterations. So x is still equal to -1/4, y is equal to 1/2, z, we just found z is equal to -1/6, and y and w is still equal to 1, which was our first guess, and we're looking for w. So w is going to be given by this equation here, which is basically -1 plus 1/2 z. So 1/2 times z, which was -1/6. We just found z. So therefore, this is going to be -1 plus, well, minus 1/12. And w is basically going to be 12, this -12 minus 1, so -13/12. That is going to be our w. Let's go on. Let's go on here and go to, well, iteration. There we go. So iteration 1, well, I'm sorry, it's 2, step 1. So we're gonna do this again. So those are going to be our iterations, and those are going to be our values. So we basically said that x was equal to negative 1 over 4, y was equal to 1 over 2, z was equal to negative 1 over 6, and w we have just found w, so and was equal to negative 13 over 12. I'm just gonna underline those, all of them, because we have to find them all over again. So x that we're gonna be given by this equation here. So negative 1 over 4 is a scalar, it's not dependent by anything, minus 1 over 4 y, so it's dependent by y, plus 1 over 4 w, so it's dependent by w. Therefore, it's going to be given by negative 1 over 4 minus 1 over 4 times 1 over 2, our value for w, y, plus 1 over 4 times negative 13 over 12, which is our value for w. So x is equal to negative 1 over 4 minus 1 over 8 minus 13 over 48. So x is equal to 48, negative 12, negative 6, negative 13. So x is actually equal to negative 31 over 48. There we go. And let's go on. So iteration 2, step 2. So those are going to be our iterations values. There we go. So negative 1 over 4, y still 1 over 2, z, oh well, I'm sorry, x is equal to negative 31 over 48. So x is equal to negative 31 over 48 because we have just found x. So y still equal to negative 1 over 2, z is still equal to negative 1 over 6, and w is still equal to negative 13 over 12. So we're looking now for y, z, and w. So y was actually given by this equation here. So basically 1 over 2 times z, and therefore it's going to be given by negative, well, 1 over 2 times negative 1 over 6, because the z. So, oh, I did it, yeah, it's 1 over 2 times z. Okay. Yeah. Okay, so basically this is negative 1 over 12. There we go. So let's go on again. Iteration 2 is almost over. Step 3. Iterations, values. X is still equal to negative 31 over 48. Y is now equal to negative 1 over 12. Z is equal to negative 1 over 6, and W is equal to negative 13 over 12. And we're now looking for Z. We still have to look for W. So Z, so we're going to be given by this equation here. So the equation here is 1/3 minus is a scalar, it's not dependent by anything, as I always say, minus 1/3 y is dependent by y, minus 1/3 w is dependent by w. And therefore, our z is going to be given by 1/3 minus 1/3 times negative 1 over 12 minus 1/3 times negative 13 over 12. So z is 1/3 plus 1 over 36 plus 13 over 36. So z is actually equal to 12 plus 1 plus 13 over 36. So z is equal to 26 over 36. Well, everything, I can divide everything by 2, so this becomes 13 over 18. And now I'm gonna go on with the very last iteration. So iteration 2, step 3, the very last step of the iteration 2, or the complete iteration 2. So iteration 2, step 4. I'm sorry, step 3 was the one I already did. So iterations, values, as always. So x is still going to be equal to negative 31 over 48. Y is still going to be equal to negative 1 over 12. Z is still going to be equal to negative 1 over, oh well, no, to 13 over 18. So to 13 over 18. And W negative 13 over 12. There we go. So W. Okay, so let's do this. W is actually going to be equal to negative 1 plus 1 over 2z. So this is given by this equation here. So as always, negative 1 is a scalar, we'll leave it there, plus 1/2 times 13 over 18, which is the value for z we have just found here. So W is equal to negative 1 plus 13 over 36. W is therefore equal to 36, negative 36 plus 13. So W is equal to negative 23 over 36. Okay, so therefore our values are, well, x equal to negative 31 over 48, y equal to negative 1 over 12, z is equal to 13 over 18, and w is equal to negative 13 over 12. But you know, in the other example, we basically used, well, we basically approximated. So we use the machine numbers, so the ones that are not, you know, perfect because they are approximated. So if we had to approximate those values in order to compare with the one we found in the, you know, in this very same matrix in system of linear equation, but that we did in the former video and the other example, but starting with completely different set of values, so starting from a completely different point, we're going to have to approximate those. So in order to compare them, let me approximate those. So this is actually almost like negative 0.645 is almost like negative 0.083. This is almost like 0.722, and this is almost like negative 1.083. So as you can basically see, if you compare them with the one we found in the other video, they're not, you know, so far from the one we found. So, you know, basically what we have found, what we have shown is that it doesn't really matter where you start from. It's just a matter of how fast it's going to converge to your desired value.